Google Classroom, and that are actually for your self-practice, okay? Itu untuk self-practice. So I really hope that you can try. Just a preparation for your quiz, your coming soon quiz this week, okay? So let's get started with topic 4, and this topic will be title reaction kinetics, and if you refer to your textbooks, it's going to be jauh sikit chapter dia. You need to go to chapter 16. Chapter 16. Okay, so you should find these in your textbooks, okay? Chapter 16, kinetic rates and mechanism of chemical reaction. Okay. So as far as you know, what kind of factor that can affect the rates of reaction? Have you learned some backgrounds on the rates of reaction at school?
Concentration.
Okay. So yeah, one of the factor that can affect rates of reaction will be concentration. What else that you know?
Temperature.
Temperature.
Yes, that's correct. Temperature also one of the factor.
Surface area.
Surface area, yes, that is also one of the factor. What
Pressure,
else?
pressure, madam.
Pressure.
Constant, teacher. Madam.
Apa-apa. Pressure, kita tengok pada points of view macam mana kita punya discussion. Okay, it can be one of the factor too. Yes, tadi siapa saya? Arif,
Makin.
Mankin, yes, that's correct. Also, catalyst. Okay, so these are few factors that can affect our rates of reaction. And by right in this topic, we are going to focus on 3 factors only. 3 sahaja. Kita akan fokus on the concentration. Okay, and then we are going to focus on the temperature factor. And last but not least, we are going to discuss about catalyst. How catalyst can affect the rates of reaction. 3 saja. Okay, yang lain-lain tu it can be one of the factor too, but we are not going to discuss other factors in our syllabus. Okay, so these are all the topics that we are going to discuss. Okay, and you can see there are so many calculation also in this topic, and some of the calculation also will involve some function that maybe you need to explore. Okay, macam ln function semua akan ada sedikit kita guna dalam topik ni. Dia ada sedikit application of math dalam calculation kita dalam topik ni. Tak apa, kita tengok one by one nanti later. Okay, so this is the definition of kinetics. Is the study of reaction rate. Okay, so when we mention the word chemical kinetics, then we know that we are studying the reaction rates and what are the factors that affect them. Okay, and how we measure rates. Okay, so reaction rate is the change of concentration of reactants. So our keywords kat sini adalah how we measure the rates of reaction is by measuring the changes of concentration. Sama ada, it can be concentration of reactants and it also can be concentration of product per function of time. Okay, so that is how we measure the reaction rate. Okay, seterusnya, if you refer to this slide, okay, this is figure 16.1, and you can see this is basically how we measure the rates of reaction. By right, you can see there is a time function kat sini. Kita monitor masa kat sini, okay, and we know that this is the beginning of chemical reaction, permulaan dia, okay. And then if you look at our chemical reaction, sebenarnya ada 2 jenis kat sini. Ini adalah chemical reaction pertama, ini chemical reaction kedua, okay. And you can see for the first one, the purple molecule representing a reactant, okay, and then the green molecule is representing products. So initially, in the beginning of chemical reaction, you can see we have a very high concentration, okay, high concentration of reactant, okay, and but then when the time goes by, there will be a certain amount of products started to be produced. Nampak, kita tengok selepas beberapa mungkin second ke beberapa minit ke, tengoklah kepada masa yang kita measure, then there are some presence of some green molecule showing that the product is starting to be produced, okay. And then you can see from time to time the concentration of our purple molecule reducing. So this is a very important information that we should understand from this diagram, menunjukkan when our chemical reaction started, the concentration of reactant decreases, and at the same time the concentration of product increases. Sebab tu dekat hujung ni kita tengok there are more green molecules as compared to purple. And it's going to be the same as the second one. Cuma sekarang ni kita bezakan, is it the first one or the second one is faster or slower. Okay, so itu kita punya fokus lah dalam topik ni, faster or slower. Okay, and then when we are talking about reaction rates, these things or these concepts are around us every day. Okay, beli buah, okay, kita beli buah, mula-mula hari pertama is very fresh. And then you put it in the basket and then you leave it for a few days, lupa nak makan. And then contohnya pisang is ripening, masak, lepas tu lama-lama jadi hitam. So that's the process of changes, okay? Yang mana how fast the changes take place adalah yang kita panggil sebagai reaction rate. So some of the reaction rates can be instantaneous, okay? Boleh berlaku dengan secara cepatnya. But then some of the reaction rate takes a very long time to be completed. Okay, alright. So ini yang kita discuss tadi, factors that influence reaction rate, and as I said, by right kita nak tengok kepada concentration, temperature, and also catalyst only. Okay, this is just some background knowledge for you, yang mana in which the effects of surface area also important. Yang mana definitely it will affect the rates of reaction, but we are not going to discuss. So you all boleh tengok figure 16.3 ni as a reference only. Okay, so let's move. So when you have a chemical reaction, okay, you should understand bila berlakunya tindak balas kimia ni, we know that all bond must be broken in the reactant. Within reactant tu kita tahu kita ada ikatan-ikatan lama kan. So these all bonds must be broken. Okay, and of course, in order to break a chemical bonds, the reaction needs, ataupun the molecule needs a certain amount of energy. Okay, and in order to initiate the bond breakage tadi, the molecule must collide to the walls of container. Must collide to each other. Okay, so the word collision kita dah banyak guna dalam topik gas kan. So dalam topik reaction rates also kita akan guna a collision theory to describe our rates of reaction later, in part 2 later. But then what we should know is, in order to have a chemical reaction, all bond must be broken and it will be initiated by collision. Okay, and then when the old bond is broken, barulah the new bond can be formed. Okay, so this is the process that take place in a chemical reaction. Dalam semua tindak balas lah, maknanya ini akan berlaku. So when the new bond are formed, then definitely we are starting to produce products. Okay, so generally tadi kita dah tahu cara kita measure rate adalah by measuring the changes of concentration. Concentration apa? It can be both reactants and also products. So mathematically, macam mana kita nak susun kita punya measurement of rates of reaction? Katalah anggap kita ada this reaction, A producing B. Okay, so yang mana kita tahu this is reactant. Adam Arif, could you please? Okay. Alright, so you can see that A ni, A reactant. Kita dah tahu dah this is reactant. Okay, and this is products. And if you want to measure the rates of this reaction, then our formula will be rate equals to change in concentration of A. And we know that A tadi adalah our reactant. Okay, and then divide by change of time, change in time. So, yang mana mathematically bila kita nak cari change ni it can be represented by the symbol of triangle ni. Kita boleh letak simbol delta ni, delta. Okay, and then in chemistry we can always represent concentration by using square bracket. Setiap kali kita buat square bracket dalam chemistry bermaksud dia referring to concentration kan. Yang mana ini adalah concentration of our reactant. Okay, and mathematically cara kita measure our change in concentration adalah concentration A2 minus concentration A1 ataupun concentration final tolak initial. Okay, final tolak initial bahagi dengan T final tolak T initial, ataupun kat sini kita label dia sebagai T2 T1 A2 A1. Okay, so it is always understood that kita punya formula bila melibatkan delta ni, dia akan final tolak initial. Okay. Alright. And then in this case, because of we are talking about concentration kan, ni concentration, okay, divide by delta T kat bawah ni. And because of A ni adalah reactant, and tadi in the previous slide kita tengok concentration of reactant decreasing kan, makin lama makin berkurang. So because of that, to indicate that process yang berkurang tadi, decreasing tadi, we are going to use negative sign. Kita akan letak negatif kalau dia adalah reactant, showing that the concentration of reactant is decreasing. Okay, but if we are measuring the changes of concentration of B, then kita akan tulis rate is equals to changes of concentration of B over delta T, in which we know that sama juga concentration final tolak dengan concentration final B, then kita concentration final B tolak dengan concentration initial B minus with T final minus T initial. Tapi dalam case ni, because B is a product, then we are going to use a positive sign showing that in a chemical reaction, concentration of product increasing. Okay, so clear up to this slide?
Clear, madam.
Okay, so that's how we measure the rate. Okay, and then, alright, yang ni madam nak tunjuk kat mana you all boleh dapatkan dia. Okay, so if you refer to your textbooks, you can go through sampailah kepada sini. Okay, so tadi kita dah cerita pasal concentration of A with the negative sign kat situ. Okay, ini yang kita discuss tadi, and concentration B with a positive sign there. Okay, so now what I'm going to introduce to you adalah there are 3 types of rates yang kita kena kenal. Okay, terms dia. So pertama, kita panggil dia sebagai average rate. So average rate, if you look at the definition, because I don't have definition on my slide, but you can refer to your textbooks. Okay, so you can see that average rate, you can see right, yang ni memang media tak boleh enlarge. So average rate adalah sebenarnya rate measured within period of time. Dia kata, sebab dia kata kat situ, over a given period of time. Kita ada a period of time interval. Okay, rate measured in a certain time interval. Kita ada masa tertentu. Contohnya, let's say if you want to find what is the average rate within 60 second. Maksudnya kita nak ukur rates of fraction in between 0 second to 60 second. Within 60 second. So kita ada time interval as I said tadi. So this is what we call as average rate. So if you refer to the slide now, katalah, katalah kita tengok ni, I think I just want to show here because I want to conteng dia. So kita tengok kat sini, this is actually the same graph as just now. And if let's say we want to find the average rate of this reaction within 60 seconds, so it will involve, korang ada belajar tak tangent dulu dekat sekolah? Did you learn about that? Tangent?
Ada.
Tangent, yang in which
Ada.
you need to find the slope of tangent to get the to get the average rate, to get the instantaneous rate. So for example, as I said just now, if you want to measure the changes of concentration tadi dalam buku tadi, dia nak cari delta O3, okay? Yang mana yang ni, this is because of my iPad is not compatible with this slide, but I really hope that if you download my lecture note and you open it in your laptop, semua sign keluar. Dia equation yang sama je dengan yang ni, yang mana dia punya equation adalah C2H4 plus O3 producing C2H4O plus O2. So sekarang kita nak measure concentration of O3 within 60 second, and we know that O3 is a reactant. So sebab tu kita tengok kat sini dia punya equation, dia punya expression adalah rate is equals to negative concentration delta C2H4 over delta T, and it is also equals to negative delta O3 over delta T. Sebab apa? Negative tadi dia adalah reactant, decreasing concentration. Okay, and we always measure delta change, delta meaning that we are referring to changes. And then square bracket is for the concentration. Okay, so go back to our average rate tadi. Bila kita nak cari within 60 second, So kita kena tengoklah daripada graf ni. Okay. It is between 0 to 60 second. Yang mana kita tahu 60 second is our concentration final. Okay, this is concentration final. And this is our concentration initial. Kan? And then yang mana kita punya formula tadi, delta O3 ni, kita kena tolak concentration final. Okay, concentration final. Tolak dengan concentration initial. So yang mana kita punya concentration final adalah 1.1 times 10 to the power of negative 5. Kat sini tak keluar. Okay, semua ni sebenarnya negative 5. Negative 5. Okay, let me double check. Tadi original dia. Okay, so you all tengok kat sini. The original one, semua negative 5 kan. Cuma dekat slide ni dia tak keluar negatif. Okay, and then lepas tu kena bahagi dengan of course T2 atau T final and T1. So in this case, our T final adalah 60 second minus with 0. And for the concentration final, kita ambil value ni 1.10 darab 10 kuasa negatif 5 minus with 3.2 times 10 to the power of negative 5. Which is, our calculation here can be represented by A. Okay, kalau kita cari dia punya tangent tu kan. Okay, so this is 3.2, kat sini 3.2. Okay, and then satu lagi 1.1. Okay, so this is 1.1. 1.1. This is 3.2. Okay, so kita akan buat all the dashes line. Okay, and ini dia punya tangent lah. Okay, so that is how we get the average rate from the graph. Or you can simply do the mathematics. Tolakkan sahaja nilai dia. So kalau korang tolak, okay, let's see the solution here. Nampak kat sini? And don't forget, because O3 is reactant tadi kan, so in our calculation, don't forget to put negative sign. Sebab sebenarnya, kita kena make sure our value yang kita dapat ni adalah a positive value. So, kalau dia adalah reactant, yang mana bila kita tolak final, tolak initial, nilai final kita tu mesti lebih kecil. Contohnya dalam case ni, our concentration final is 1.1, sedangkan kita punya concentration initial adalah 3.2. So of course bila kita tolak dua tu kan dapat negatif kan. Tapi by right our value here must be positive, so that's why we must put negative sign. So itu dari segi perspektif mathematics lah. Yang mana kenapa kita letak negative sign, because we want to make sure that our value here will be positive. Tapi sedangkan kalau in chemistry perspective, we put negative sign because of concentration of reactant decreasing. Dia ada dua purpose kat situ. Kenapa kita kena letak negatif. Okay. So bila kita, when we do the calculation, tolak, kita akan dapat our rates of fraction. Yang mana this is decreasing. Nilai dia adalah 3.5 times 10 to the power of negative 7. And because of concentration is always measured, concentration over T and massa tu depends, but most of the time kita guna second. Kita guna second. And concentration kita dah belajar dalam topik 2. Concentration adalah mole over volume, right? So sebab tu unit rate is always MS negative 1. Okay, MS negative 1. Yang mana M besar, S is the second. M ni adalah concentration, yang mana kita tahu formula dia adalah mole per liter. Mole per liter kan? Ini adalah M bahagi dengan second. So that's why unit dia adalah mole per liter per second. So there are a few ways for you to express the unit. Sama ada nak express dalam bentuk ni, this is the original one. And then kalau kita ringkaskan, dia akan jadi mole per liter per second. Ataupun you can make it as simple as possible by replacing mole per liter tu dengan M besar. Sebab itu adalah molarity. So the unit can be as simple as this, MS negative 1. Kalau korang tulis macam ni pun, it is understood that this is mole per liter per second. Okay, so is that clear for the average rate within 60 seconds?
Clear, madam.
Okay.
Yeah, madam.
Alright, so now for information, when we take the average rate within a different time interval, sebab keyword untuk average adalah time interval kan. So throughout a chemical reaction, dia sebenarnya dia ada satu tempoh dia, kita punya chemical reaction rates dia adalah laju. Tapi ada satu tempoh tu mungkin dia slow down a little bit. Okay, lepas tu dia laju balik. So that's why bila kita ambil average rate within a different time interval, then by right the value of average rate will be different. Okay, sebab dia punya kelajuan tu tak sama pada different time interval. So contohnya kalau kita tengok dekat dalam buku ni, mula-mula tadi kita ambil for the first 60 second kan. Lepas tu katalah kita ambil, mana dia cakap kat sini, dia ambil for the first 10 second pula. For the first 10 second, yang mana kalau korang tengok balik table tadi, okay, if you refer to the table, the first 10 second is referring to this. Kan? Jadi maknanya this is our final and this is our initial. Okay, so if you put the value 2.42 times 10 to the power of negative 5 minus 3.2 times 10 to the power of negative 5 bahagi dengan T2 kita 10 tolak kosong kan, T2 tolak T1. So kalau korang kira dia akan dapat negative 2.4 times 10 to the power of negative 5 tolak dengan 3.2 times 10 to the power of negative 5 bahagi dengan our time interval the first 10 second. Then kita akan nampak kat sini kita punya average rate is totally different from the previous one. It is 7.8 times 10 to the power of negative 7. But don't be surprised because this is the facts dia lah. Sebab kita punya rates of fraction dia sebenarnya berbeza-beza within a different time interval. Okay. And you can also test balik. Test pula for the last 10 second. Tadi first 10 second, first 60 second, first 10 second, now last 10 second. Yang mana kita punya time interval adalah between 50 second to 60 second lah, 10 minit terakhir kan. So that's why if you take the reading from the table tadi, maknanya kita sekarang measuring the average rate between 50 to 60 second. So kita ambil lah nilai dia. 1.10 darab 10 kuasa negatif 5 dengan 1.23 darab 10 kuasa negatif 5 dan bahagi dengan 60 tolak 50. So you will see that our value now, the average rate is 1.3 times 10 to the power of negative 7 ms negative 1. So this part is just to show you that if you are referring to a different time interval, you are going to get a different average rate. Okay. So again, as I said, average rate is referring to rate measured within time interval. Okay. Alright. Ataupun over period of time. Okay. So the second terms of rate is called instantaneous. Okay. So instantaneous ni sesuai dengan nama dia, instant. Meaning that this is the rate where we measure at a certain or specific time. Okay. So for example, what we have in these books adalah what is the instantaneous rate if measured at 35 seconds. At 35 seconds meaning that kalau kita refer back to the table, okay, to this table, originally if you refer to this, line asal dia yang ni je, okay, because we are measuring the concentration of O3 kat sini, okay. And of course, as we know that O3 is a reactant, that's why kita punya curve ni dia menurun ke bawah. Okay, dia makin menurun because it will show to us that concentration of reactant decreasing. That's the first point. Tadi Maida lupa nak bagi tahu. Sebenarnya line sebenar dekat graf ni adalah line ni je. Line ni sahaja yang mana itu adalah representing what happened to the concentration of O3. Lepas tu tadi kita boleh guna line tadi untuk dapatkan average rate by using the concept of tangent, okay, slope of tangent. And same goes to instantaneous rate. In order to find instantaneous rate at 35 second, dan kita sama juga kita kena dapatkan slope of tangent. Okay, slope of tangent. So kalau ramai yang dah lupa ke macam mana nak cari slope tangent semua ni, maybe you can refer back to, mungkin boleh tengok dekat YouTube video ke. Tapi tak apa, nanti sekejap lagi kita buat exercise regarding this. Okay, so sekarang kita nak cari at a specific time which is 35 second and should be somewhere here lah, 35 second. Okay, yang mana of course you need to have a ruler. Okay, ambil satu ruler and then you must draw a line that touching the point at 35 second. Kena ambil satu pembaris lah, pembaris, draw a straight line there. Okay, and then basically you are going to find dia punya formula adalah sebenarnya y2 tolak y1 bahagi dengan x2 tolak x1 lah kan, to get the slope. So in this case if you tapi Maida tak tunjuk contoh yang ni sebab dia punya scale tu terlalu terlalu besar. Okay, scale dia tak ada senggat kat situ. So it's quite difficult for me to explain dari segi value yang kita ambil. But of course sometimes dia akan lari sikit lah. Kalau student A ni ambil value ni, student B ambil value lain pula. So our value will be slightly different, but of course kita ada range dia lah, the accepted range. Okay, but basically the general formula of getting the slope of tangent is y2 minus y1 divided by x2 minus x1. Okay, daripada line ni lah yang kita buat. So daripada ni apa yang kita dapat kat sini adalah by right for this one, the value is 2.5 times 10 to the power of negative 7. You can focus on point number 2. Point number 2 yang mana instantaneous rate, which is rate measured at a specific time or particular of time, the value is 2.5 times 10 to the power of negative 7 ms negative 1. So that is instantaneous. So yang ketiga pula adalah we call it as initial rate. So apa pula initial rate? Initial rate is actually one of the instantaneous. Sama je. Initial dengan instantaneous sebenarnya benda yang sama. You have a specific of time. Tetapi initial rate is referring to when t is equals to 0. Bila masa equals to 0. So ini sebenarnya when we are talking about initial rate adalah katalah you have two reactants in a two different container. So masa yang kita campurkan tu, okay, katalah we are measuring the time and you akan guna stopwatch, jam randik itu, kan? Bila you campur sahaja dua reactant and then you will start your stopwatch immediately because we want to measure the initial rate. Yang mana initial rate is defined as instantaneous rate when t is equals to 0. Masa mula-mula kita nak start tindak balas tu, kita terus measure masa dia. And in most of our calculations sebenarnya kita memang banyak guna initial rate. Sebab initial rate ni is very useful because kita boleh dapat terus the reading for example and we can do the calculation. By right, we can do the data yang kita dapat ni to predict our reaction. So that's why most of the time kita guna initial rate. Okay, so to get the initial rate, we can go back to this graph. Okay, and then by right, kalau kita tengok balik, t must be equals to 0. So dalam banyak line ni maknanya kita refer kepada line B ni lah. Line B ke? Line E. Okay, line E kan? Let me double check. We are referring to E, yes. Okay, so it's line E yang mana kita punya T is equals to 0. So ini pun sama lah, you need to get a ruler, dapatkan pembaris and draw a line kat sini. So this is how we get the tangent, the slope of tangent. So dalam case ni, the value will be berapa kat sini tak bagi tahu pula. What's the value of rate? Okay, tak apalah dia tak bagi tahu kat sini, but it's okay. Let's do one question from your workbook. Okay, soalan nombor, silap. Soalan nombor berapa Okay, number 1. Okay, do you have your workbook together with you?
Ada.
Okay, so untuk soalan ni is easier. Sebab scale kita kecil, so kita boleh nampak lah kita ada scale untuk setiap 0.1, 0.2 kan. Senang sikit kita nak kira. Okay, so dia kata the change in concentration of hydrogen peroxide plotted against time is shown in the graph below. So bila kita tengok saja, this is concentration of H2O2 versus time. So definitely we are measuring the changes of concentration. Cuma sebab tak ada equation kan dia just bagi tahu it is hydrogen peroxide. So kita nak tahu ini reactant ke produk kan. So kita tengok dekat dia punya trend of curve. Yang mana nampak tak dia punya curve ni menurun ke bawah. So we know that in this case H2O2 is a reactant. Kan? Sebab dia punya concentration makin berkurang. Sebab kita boleh baca apa sini je. Our initial concentration ini adalah T kan. Ini masa. So it is 0 second. So it is at its highest concentration, 0.9. So kita tahu itu adalah initial concentration of H2O2, and when the reaction started, bila masa pun bermula daripada 0 kepada 10 second, etc., yang mana kita akan nampak concentration dia drop. So yeah, H2O2 here is a reactant. Okay. So soalan dia kata determine the average rate between 10 second and 15 second. So maknanya kita nak antara 10 to 15 second. So this is our time interval. Okay. And bila ada time interval macam ni, so betul lah, we are looking for average rate, right? So korang cuba. Daripada tadi, contoh tadi, cuba kita buat. Korang cuba buat sendiri. Rate is equals to negative delta H2O2 bahagi dengan delta T. Okay. So which means that it is equals to concentration 2 minus with concentration 1. Meda tak tulislah H2O2 kat dalam tu. Okay, bahagi dengan T2 minus T1. Okay, so because of our T2 here adalah the maximum time lah dalam kita punya time interval. So maknanya kita refer kepada 50 second, right? So korang tengoklah kat sini berapa dia punya concentration. Okay, boleh masukkan. Lepas tu, that is our T2 and also concentration 2. And for T1, kita bermula daripada 10 second sebab dia nak daripada 10 saat pertama kan. So ini adalah kita punya 10 second. Okay, and then daripada sini kita boleh dapatkanlah concentration for T1 at T1. Okay, so what is our concentration 2? Can you give me the value?
0.0125.
0.125.
0.0125.
0.0125? Okay, by right. Sebab kita nak concentration at 50 second kan. And that's the line. That's the curve kita tu. So kita kena buat dash line sampai dia bersentuh dekat curve tu. Lepas tu kita tengoklah y-axis dia. Which means that the value is?
0.2.
0.2. 0.2. Okay. At molar lah. This is molar sebab we are referring to concentration. Lepas tu minus with T1 kita adalah 10 second tadi kan. So kita pun dash line sampailah dia bersentuh dengan curve ni. So kita tengok dekat y-axis kita berapa kat situ.
0.7 madam.
0.7 molar. Okay, kita dah dapat yang atas. Bahagi dengan masa, masukkan je lah 50 second minus with 10 second. So berapa nilai dapat kat sini?
0.0125 madam.
Oh, tadi bagi jawapan dah. Okay.
Yes.
Yes, okay. So betul lah jawapan dia satu point berapa tadi? 0.0 berapa?
0.0125.
1.25 times 10 to the power of negative 2 lah kan. And unit dia adalah ms negative 1. Okay, yang lain okay?
Okay,
madam.
Alright.
Okay, madam.
So by right, if the question asking for average rate, you all tengok saja time interval given, lepas tu draw a dashes line and you can get the concentration from there. Okay, draw a dashes line sampailah the line touching the curve, then you akan dapatlah dia punya concentration 2 dan juga concentration 1. That is for average rate. Okay, and then for the instantaneous rate. Untuk instantaneous rate pula kita nak dalam case ni sebenarnya soalan ni dah bagi dah dia punya tangent tu kat situ. Okay, yang mana kita nak instantaneous rate at 20 second. So maknanya kita punya line adalah daripada 20 second tu kita naik ke atas. So kat sini. Tapi soalan ni dia dah bagi dah siap-siap. Cuba korang kira dia punya ni. So our expression masih lagi sama, delta H2O2. Okay, bahagi dengan delta T. So based on the tangent there, kita dapat berapa nilai our first dia tu. Dia lebih kurang lah kat sini satu. Okay. So that would be our concentration 2 lah sebenarnya kat sini kan. Okay. And then so it's going to be somewhere here. Berapa tu? Tengah-tengah Dia betul-betul tengah scale kan. So maknanya it is berapa? This is the concentration 1.
0.65.
Yeah. So asal tadi 0.300 molar minus with ke atas tu adalah 0.650 molar. Okay, sebab dia betul-betul tengah scale tu antara 0.6 dengan 0.7. So confirm lah, confirm 0.650. Okay, bahagi dengan kalau bahagi dengan ni, bahagi dengan berapa kat sini? So kita kena tengok kat sini lah. Okay. Ini 30. Lepas tu ni pula 10. Dapat berapa? 0.3 minus with 0.650. Okay. And divide by 30 minus 10. What's the answer?
0.0175.
75 So 1.75 darab 10 kuasa negatif 2 and the unit is also ms negative 1. Okay, so how about yang lain? Okay ke? Example on how to find average rate and also instantaneous rate.
Okay, madam.
Okay?
Okay, madam.
Alright, so no questions Okay? Alright, so now let's move to the next one. Okay. Okay, so let's move to the next slide. Okay. So in this case by right, you should understand when we are referring to a graph like this, okay, you will see there are two different curves kat situ and please take notes that here it is concentration versus T. Okay. And then based on our reaction just now, we know that both C2H4 and also O3 are our reactants. So that's why kalau graph yang tadi kita fokus kepada O3 kan. So in this graph we are focusing on C2H4 and because C2H4 is also a reactant, that's why kalau tengok dekat curve yang warna merah tu, curve dia menurun ke bawah. Okay. Our initial concentration adalah 1 molar and because of this is concentration, the concentration will be decrease. Okay. And at the same time, pada mula-mula tindak balas, tengok kat sini, kosong kan? This is T equals to 0. Yang mana our concentration of product also equals to 0. Kan? Pada awal-awal tindak balas, memang tak ada lagi produk dihasilkan. That's why concentration of product is equals to 0. But as the time goes by, kita akan nampak the concentration of, in this case, O2. And we know that O2 is product. So concentration of product, if you refer to the blue line, increasing. Okay, so that's the difference between reactant and also concentration. And as we know that the way we express also will be totally different. Yang mana ini adalah rate is equals to negative lah sebab C2H4 is a reactant. Okay, and it is equals to concentration of O3. O3 pun reactant, right? So kena ada negative sign kat depan. So ini kalau katalah you all download my lecture notes and the sign also do not appear, tolong tambah sebab ini adalah reactant, so dia kena ada negatif. Yang ni pun kena ada negatif because it is also a reactant. Okay, but kat bawah ni because both are products, so maknanya kita akan letak ataupun tak letak pun understood that it is a positive sign. Okay, boleh? So that is how we write the rate expression. So apa yang kita dah belajar, how we write the rate expression. Then kita tengok kepada sama ada we are expressing concentration of reactant. Then kita akan guna negative sign, ataupun expressing concentration of products, we are going to use positive sign. Okay. And then to get or to calculate the rates of reaction, by right we are measuring the changes of concentration. So our formula is always final minus with initial. And divide by time pun sama, time final tolak dengan initial time. And the unit of rates of reaction is always ms negative 1. So these are the things yang kita dah cover. Okay, and then to express the rate, it depends on what kind of terms yang kita guna. So kita ada 3 tadi, average rate, kita ada instantaneous rate, and the last one kita ada initial rate. Okay, so let's move to the next slide. Okay, so in this slide, kita masih lagi fokus kepada expressing the rate. But in this case, we have a different reaction. Kita ada reaction apa ni? Kita ada HI reacted with I2 to produce 2 mole of HI. So in previous example, our balanced chemical equation only involve 1 mole. Dia tak ada yang 2 mole kan? Tapi in this equation, kita ada yang mana both reactants will produce 2 mole of HI. So apa akan berbeza in terms of expression when we have more than 1 mole? Then let's have a look at its expression. So the expression here will be rate is equals to, so hydrogen gas adalah reactant, so sama juga kena letak negative sign, and this one must be square bracket. Memang kena follow ni When the question asks you to write the rate expression, memang kena letak negative dan juga square bracket. Okay, and then it will be equals to, okay, I2 is also reactant, so letak negative juga kat sini, square bracket, and please take note here. Because if you refer to the balanced chemical equation, we have 2 mole of HI. So when we write the expression here, then kita kena buat dia jadi 1 over coefficient. Okay, 1 over coefficient. So disebabkan kat sini dia 2 mole, so dia akan jadi 1/2. 1/2 concentration of HI. Okay, which means that sebenarnya apa yang kita boleh kata adalah yang ada negatif ni, yang ada negative sign ni, kita panggil dia sebagai rate of disappearance. Okay, that's the terms yang kita boleh panggil juga. To represent the negative sign tadi, kita panggil dia sebagai rate of disappearance. And then yang ada positive sign ni ataupun kepada produk lah, tadi ini sebenarnya untuk reactant kita panggil sebagai rate of disappearance, and untuk produk kita panggil sebagai rate of appearance. So understood lepas ni bila kita mention the word appearance, then kita tahu we are referring to the rate of products. But when we mention disappearance, then we know that understood we are referring to the rate of reactant. Okay, alright, and go back to the coefficient just now. Bila kita baca kita punya rate expression ni, kita kata rate of appearance of rate of I2 ni, kalau kita rate of disappearance of I2 ni sebenarnya kalau kita compare dengan HI, dia sebenarnya separuh daripada rates of disappearance. Half of rate of disappearance based on our rate expression. Okay, and macam mana kita tahu dia separuh, dia 1/3, 1/4? Then as I said, it will depends on the coefficient from balanced chemical equation. Okay, so yang bawah ni tak apa, abaikan saja, abaikan, because kita memang, this is the way we write the expression. Okay, so generally, kalau kita ada equation like this, okay, A adalah number of mole lah, this is number of mole. Mana kita dapat ni? Daripada balanced chemical equation, right? So A campur B produce C plus D. So dalam case ni kita ada a specific coefficient, okay, from the balanced chemical equation. So our rate expression will be rate is equals to, and because of A is reactant, so kena letak negative 1 over A because it is A mole, darab dengan dia punya concentration of A over delta T is equals to, ini pun reactant, so negative 1 over B, the coefficient from balanced chemical equation, of concentration B per unit of time, delta T. Okay, and then it is also equals to, so C dengan D dua-dua adalah produk kan. Jadi no need to write negative sign dah. Sebab kita refer kepada appearance. So dia akan jadi 1 over C concentration of C equals to 1 over D concentration of D. So dua ni kita panggil dia sebagai disappearance. Yang ni adalah appearance. Okay, boleh? Okay, so now let's see an example on how to use this rate expression. I don't know why the sign missing, semua hilang. So by ini pun patutnya plus This is 2 hydrogen gas, 2 mole of hydrogen gas, reacted with 1 mole of oxygen gas to produce 2 mole of H2O gas. So by right, this is our equation lah. Okay. So soalan pertama dia kata express the rate in terms of changes in H2, O2 and H2O with time. Cuba korang bagi kat madam, what is the rate expression? So bila ada perkataan expression, it is understood that you must write the expression involving appearance dan disappearance. Kena ingat bila soalan kata express the rate, dia melibatkan disappearance and also appearance. So we are going to start our rate expression by writing rate is equals to, okay, so give me the disappearance.
Negative.
Negative.
1 over 2 madam.
1 over 2, yes, that's correct because kita nampak kat situ ada 2 mole of hydrogen gas. Delta
H2.
H2 over delta T.
T.
Okay, yes, that's correct. Okay, the next one. Terusnya,
Negative.
negative.
Delta O2
Delta O2
over
over
delta T.
delta T. Okay, thank you Adam. Okay, yang lain? Okay, seterusnya yang lain pula. Equals to. Okay, untuk disappearance dah selesai. Okay, how about the appearance?
1 over 2.
Okay, Koyum. So, produk kita pun 2 mole, right? So, dia akan jadi 1 over 2
Delta H2O
delta H2O over
delta T.
delta T. So, that would be our rate expression. Okay, so inilah jawapan kita. Okay, clear semua for A?
Yeah.
Okay, alright. So let's move to B. Dia kata when oxygen gas is decreasing. So bear in mind when we are talking about rates of reaction, when you have the word decreasing here, showing that this value has a negative sign. Dia tak tulis kan, dia cuma tulis decreasing at 0.23 mole per second. Molar per second. And the question is asking for rate of H2O increasing. So the word decreasing kat sini, you all kena ingat bila ada perkataan decreasing in the questions, then value yang kita nak guna nanti kena letak negative value. Kalau tak, kita akan dapat jawapan positif negatif dia tu terbalik. Okay, so kena letak. So dalam case ni kita nak compare antara dua rate sebenarnya. Yang mana dia kata rate of O2 decreasing adalah 0.23. Yang kita nak cari adalah what is the rate of H2O. So kita keluarkan yang rate yang kita compare ni, rate is equals to negative O2, delta negative O2 delta T equals to 1/2 delta H2O over delta T. Ini, dua ni. Dia punya relationship mentioned in B, right? Okay, so sekarang dia bagi 0.23 itu adalah rate of decreasing. So you akan letak macam ni, negatif. Lepas tu dalam soalan kata rate ni adalah nilai dia decreasing negatif 0.23. Okay, nampak Ada perkataan decreasing, negatif ni memang ada dalam expression kita dah. Kita memang take as it is sebab dia memang dah ada dalam expression. Cuma bila kita nak substitute the delta O2 over delta T, sebab dalam soalan dia mention decreasing at 0.23, maka kita kena masukkan nilai dia negatif 0.23. 0.23 macam tu. Okay, and then it is equals to 1/2 delta H2O delta T. So soalan dia tanya what rate is H2O increasing? Soalan nak yang ni sebenarnya. What is this value? Apa nilai dia? So, mathematically, kita akan pindahkan 1/2 ke belah sana. Okay. Dan kita akan dapat jawapan dia berapa?
0.46.
0.46 ms negative 1. Yang mana nilai yang kita dapat adalah a positive value. So you bayangkan kalau kita tak letak negatif 0.23 kat dalam kita punya value of O2 over delta T, jawapan kat bawah ni kita akan dapat negative value. So bila dapat negative value, meaning that salah lah sebab soalan kata what rate is H2O increasing. So kalau dapat negatif dia sebenarnya tak tally lah. Negative means decreasing. So that's why every time when you have this kind of question, kalau disebut perkataan decreasing, kena letak negatif in front of the given value. Okay? Alright? Okay? So do you have any question?
Tak ada, madam.
Tak ada Okay, what time now? Okay, baru 9:26. So almost 1 hour. So maybe I go with you one more example on these sample problems. Okay, and then I think mungkin kita akan sambung in the next class je lah. Okay, so let's see this. Okay, yang ni this is the solution yang kita dah buat tadi. So this is the answer lah, 0.46 yang kita buat tadi. Okay, so kita tengok one more yang ni. Dalam buku, so you can go straight away to, okay, ini adalah soalan yang kita discuss tadi. So let's have a look at dia punya follow up problem. Yang ni. Okay. So maybe kita boleh buat, nak buat apa? Kita buat 16.18. Okay. So cuba you all buat dulu on your own and after that we discuss. Okay, so in this question, dia kata balance the following equation first. You need to balance the equation first, okay, and then you need to express the rate in terms of change in concentration. So the word express itself showing that you need to write the rate of disappearance and also appearance. Kena set dalam kepala untuk soalan kinetic ni, untuk part mula-mula ni bila dia mention express the rates, then kita memang refer kepada appearance and disappearance. So mula-mula korang kena balancekan dia dulu. Okay, and you can give me the balance chemical equation. And 2 apa tadi? And 2 O3. Okay. So, what is the balance chemical equation? Anyone want to try?
NO.
How many? 4 NO.
4 NO.
4 NO. Oxygen?
1.
1. Okay. And then how about N2O3?
2.
2 more. Okay. Yes. That's a balanced chemical equation. Okay. So to answer A, okay, you need to write down the rate expression. Okay. So your rate expression always start with rate equals to. Okay. So what should be your rate of disappearance in this case?
-1/4.
Okay. -1/4.
Delta. Square bracket NO over delta T.
Okay. Alright.
Equals to delta negative. Delta square bracket O2 over delta T.
Okay.
Equals to 1/2 delta square bracket NO and 2O3 over delta T.
Okay, thank you, Jiha. Okay, so that's the correct rate expression lah. Okay, so by following the balanced chemical equation kat sini, ni satu, ini dua, dan by right kita akan dapat this coefficient lah kiranya for our rate expression. Okay, clear semua?
Clear.
Clear, madam.
Alright, so soalan nombor 2 tadi dia tanya apa? Dia tanya how fast is O2 decreasing when NO is decreasing at rate of 1.6 times 10 to the power of negative 4. So sekarang dia nak suruh compare antara ini dengan ini. So kita ambil lah dia. Kita ambil dia dua ni. Okay. Then put it here. So ini yang kita nak cari, yang diperlukan dalam kita punya calculation, and it was informed in the question that NO tu dia decreasing at the rate of 1.6 times 10 to the power of negative 4. Maknanya kita kena ganti kat sini lah NO ni. So it is equals to negative 1/4, and given tadi, berapa yang dia tak ingat lah tadi, 1.6 kan. So sebab dia kata ada decreasing, the word decreasing macam tadi juga, kita kena letak negative 1.6 times 10 to the power of berapa tadi You ingat tak? Malas nak minimize. 10 kuasa negative
Negative 4.
negative 4. Okay. MS negative 1. Which is equals to, ini yang kita nak cari. Delta O2 over delta T. So, berapa nilai dia? Okay, kita pindahkanlah. Dia akan jadi delta O2 over delta T. Ini yang kita nak cari. Negatif. Madam pindahkan ke depan je ni. Okay, delta T. Jadi bersama dengan
For 10 negative 5.
times 10 to the power of
Negative 5.
negative 5. MS negative 1. Yang lain dapat ke? Negative 5.
Dapat medium.
Dapat.
Dapat medium.
Alright, so you can see that here, our answer must be positive sebab kita dah ada negative sign dekat sini. Kita dah ada negative sign kat depan. So kalau kita tukar position of the negative sign, kalau kita nak tengok kat sini, then by right kalau kita susun balik, dia akan jadi delta concentration of O2 over delta T, then kita akan dapat 4.00 times 10 to the power of negative 5, yang mana betul lah this is referring to rate of disappearance. So either way lah, sama ada you tulis macam ni ataupun macam ni. Okay, janji maknanya kita tahu because O2 is a reactant, then definitely value dia mesti ada negative value. Okay. So nanti korang boleh try 16.1b. Mungkin kita boleh tengok satu soalan daripada kita punya workbook before we end our live class today. So kita buat dulu soalan mana yang sesuai ni, yang berkaitan dengan rate expression. So let's have a look at number 2. Okay, number 2, dia kata the decomposition of N2O5 at a particular instant in a reaction vessel is 4.2 times 10 to the power of negative 7. So the word decomposition kat sini sebenarnya menunjukkan decomposition ni maksudnya dia pecah lah, dia pecah. Okay, the word decomposition means dia dissociated, dia pecah kepada NO2 dan juga O2. Okay. So dia kata determine the rate of appearance of NO2 dan juga O2. So in the first place, you need to double check whether the equation is already balanced or not, and by right this equation patutnya kalau korang check, do the inspection, insyaAllah dia dah balance. Okay, so maknanya when we write the rate expression, dia akan jadi macam mana korang? Rate is equals to Anyone?
Negative,
Right?
negative 1/2
1/2
delta N2 O5.
over delta T. Okay. Equals to? Okay, yang lain siapa nak cuba? So equals to
1/4
1/4
delta NO2 per
equals
delta T
to
equals to delta O2
over delta T.
over delta T. Yes.
Okay. Alright, so sekarang dia kata the decomposition of N2O5 in the vessel is 4.2, and as I said, decomposition tadi menunjukkan dia berkurang lah sebenarnya. Okay. So bila dia berkurang, maknanya kita kena letak the negative sign. Okay. Kita kena letak negative sign in our value. Tapi by right dia suruh cari ini kan sekali kan. So bila dia suruh cari, kita kena buat one by one lah sebenarnya. The best adalah kita kena buat one by one. So kita buat comparison antara ini dengan ini dulu. Kita buat ni, dua ni. So kalau kita susun kan, kita nak yang ni kan, kita nak yang ni. So kita leave it there. So dia akan jadi delta NO2 over delta T kan. 1/4 ni kita pindah ke sana. Ya, bila kita pindah ke sana, dan dia akan jadi negatif 4/2 kan, betul tak? Okay, bila kita pindah ke sana, dia jadi negatif 4/2. And then given in the question adalah nilai dia 4.2, tapi sebab ada perkataan decomposition tadi, then you all kena letak negative sign. Negatif 4.2 darab 10 kuasa negatif 7 kat dalam ni. Okay.
Okay, madam.
Okay, madam.
So berapa nilai dia?
Eight point four
8.4 times 10 to the power of
87.
negative 7 ms negative 1. Okay, so that's correct. Okay, jawapan dia 8.4 darab 10 kuasa negatif 7. Yang lain-lain okay hopefully semua boleh cuba buat sekali serentak Okay, so let's calculate the for O2 pula. So untuk O2 ni kita tahu if you do the comparison, dia adalah between negatif 1/2. Okay, so negatif 1/2 delta N2O5 over delta T, which is equals to delta O2 over delta T. So yang ni senang je, kita masukkan sahaja nilai dia. Negatif 1/2 darab dengan negatif 4.2 darab 10 kuasa negatif 7. Yang ni senanglah sikit sebab sebelah sini kita terus dapat jawapan untuk delta O2 over delta T. So berapa?
2.1
Jawapan dia adalah 2.1 times
darab 10 kuasa negatif 7.
negatif 7 ms negatif 1. Okay. So very good. Okay. So sekarang that's the answer for number 2. So as a practice for you to do on your own, you all boleh cuba soalan nombor 3 nanti. Okay. And insyaAllah Meda akan tanya jawapan untuk soalan nombor 3 ni in our next live class. Okay. So do you have any questions that you want to ask before we end our live class?
Madam,
Yes.
kan Madam cakap next Friday kita ada quiz
Yeah.
Malam ke pagi?
Oh, okay. Our quiz will be done during class slot.
Okay.
Okay. Waktu kelas maksudnya kalau 891, you all punya kelas pukul 8 pagi. Makanya your quiz will be starting from pukul 8 lah. Lepas tu group Friday, Chemist kan. Group 450 hari Jumaat pukul 8 pagi. And then group 400 pukul 10 pagi hari Jumaat. Okay?
Okay, madam.
Okay. By the way, but then I can see it's not full attendance, but due to some technical problems regarding pembelian buku, ada lagi yang tak beli buku due some of the problems yang macam-macam. Okay, I have good news for those yang memang ada masalah tu. InsyaAllah our lab, visual lab will be extended. Nanti Madam akan bagi tahu sampai bila. Tapi this is only for experiment 1 sahaja. Okay, sebab you all dah nampak kan dia punya impact sebenarnya, because I'm not the one that control the date for virtual lab. Sebab bila dia dah habis due date dia, time dia akan tutup terus virtual lab tu. So nanti korang dah tak ada access untuk buat that experiment. So that's why it is very important for you to make sure you all kena submit lab tu within given time. Sebab memang slot tu memang dah difixkan bila-bila, sampai bila-bila. Tapi untuk eksperimen 1 ni sebab ada beberapa masalah here and there, so kita akan extend sedikit masa dia untuk eksperimen 1 sahaja. And then lepas tu kedua, jangan lupa termasuk bila nak buat quiz minggu depan, jangan lupa bila attach apa-apa dekat Google Classroom, tolong jangan lupa untuk tekan turn in. Sebab kalau you all tak tekan turn in, memang madam tak akan dapat lah your file tu. So you kena tekan turn in. Okay. A quiz. Okay. Hari Jumaat ni adalah our quiz 1. Nanti korang tengok balik dekat course outline. Quiz 1 ni berapa persen, berapa markah. Tapi by right dia akan cover topik 1 dan topik 2. Nak tengok dekat mana? Tutorial mana? Tutorial 1 dan tutorial 2. Okay. Topik pertama yang kita belajar hari tu dengan topik kedua. Okay. So nak study balik, tengok balik tutorial 2 dan juga tutorial 1. And definitely you can refer back to the pre-recorded video untuk mana-mana parts yang mungkin tak berapa faham. And also jangan lupa untuk try some of the sample problem dalam syllabus. That's only the tips lah untuk quiz. Okay, yang dekat GC tu adalah quizzes. Quizzes tu as I said, it is only for your self-practice sahaja. Okay, untuk sebagai revision, madam just bagi quizzes tu untuk sebagai part of revision sahaja, not the real quiz. Okay, sebab quiz kita ada total mark, if I'm not mistaken, 25. Nanti I have to check the total mark for our quiz 1 ni. Tapi dia ada soalan MCQ, multiple choice question ABCD tu, dan juga akan ada structured question yang korang kena tulis jawapan dia. So hopefully you all dah boleh practice lah macam mana nak snap gambar, nak attach, nak tukar dia jadi formatting jadi PDF. So you can practice. Sebab tu sebenarnya untuk tutorial tu hari tu madam suruh you all hantar kat GC as a practice. Okay. Alright. So okay. Alright. So do you have any other questions?
Madam, soalan berapa tadi yang madam suruh?
Nombor 3.
Oh.
Okay, nombor 3 tadi Sebab nombor 3 ni still under topik yang kita dah cover malam ni, tapi starting from topic 4 will be our next subtopic. Okay? Alright. Any other question?
No, madam.
Okay, no. So thank you very much for joining our extra class tonight. Okay? So let's close our class with tasbih kafarah in surah Al-As.
Thank you.
Thank you, madam.
Assalamualaikum.
Thank you, madam.
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 Thank you, madam.